Okay, let's get this set up here. All right, so I forgot my tripod today, so I'm leaning it against my backpack, so I hope that that is good. So we are gonna do 7.2 today, which is circles. And when it comes to the conic sections, remember we're looking at a cone and we're slicing the cone with like a knife. The easiest one to come up with is the circle. And hopefully you've seen circles somewhere in your past algebra career. So I'm going to define the circle and then we'll work through a couple circle problems. So you might not have seen this definition of the circle, and if you don't like it, don't worry about it, okay? But here's the true definition of a circle. A circle is the collection of all coordinates that are equidistant or equally distant, from a central point. Okay, so that is the true definition of a circle. So it says that we're looking from a central point. Now that central point is going to be the center, okay? And it says that all the coordinates are equidistant, meaning they have the same distance. And that distance is going to be our radius. Okay, so we've got a center and a radius. So the idea of creating a circle is to have your center and then we have a radius here. And what you're doing is like you're putting your finger on the center and you're taking this little line and you're moving it all the way around the center and you're sketching in all of the points that are equidistant. Now I'm gonna do that, but it's not gonna end up very pretty. So let's say we were to do that and I pull that line all the way around and it looks something sort of like that. And that's how we define a circle. Now, we're gonna put the circle on the XY graph and do it that way, but this is, like I said, the conic definition of the circle. Now, if this was on an XY graph, just for the heck of it, I want you to notice that it most definitely does not pass the vertical line test. And so this guy is not a function, okay? Not a function. And none of our conics from this chapter, our conic sections, none of them are going to be functions, which is why they're in their own chapter, okay? So these guys are all gonna fail that vertical line test. So when it comes to a circle, we have a formula, and the formula looks something like this. X minus h squared plus y minus k squared equals r squared. So not a function means that you're not going to have like f of x equals 2x squared plus 7 or y equals 6x minus 2. Okay, these guys are definitely going to be uglier looking with the x's and the y's kind of coexisting. So when you're given the formula for a circle, the nice thing about this is the center and the radius are right there. The center is the point HK, okay? The coordinate or the number that's with the X and the number that's with the Y. And then the radius is just gonna be R. Okay? So we have our center and radius. So if I gave you the circle, let's say X minus 3 squared plus y plus 2 squared equals 16, okay? You should be able to graph this without too much trouble if you remember the circle formula. If you don't remember the circle formula, this is just going to be a royal disaster, okay? You're going to look at this and go, I don't know what to do. But for those of us that remember the formula, we go, yes, I can do this. So the center here, and what I want you to notice up here is this is a minus h and a minus k, but it says hk. So we have to flip the signs. So our center is going to be positive 3 -2. And our radius is going to be 4. Now here's the thing when we graph. Okay, you see my circle over there. It's not great. So when I or you go ahead and graph this, I am not expecting perfection from you, but I am expecting that you take a little bit of time to do this. So the first thing I want you to do is get that center on there. So 3, -2. So there's the center. And then I want you to measure out 4, but I don't need you to measure out 4 everywhere. Maybe in the 4 main directions. So if we go up 4, 1, 2, 3, 4, we would have a point here. If we go over 1, 2, 3, we'd have a point here. Kind of think about it as if it was going down, we'll have a point there, over. So I don't expect perfection, but I don't just want like, oh, there's my circle, okay? I want it to actually fit with what the radius actually is. And then we're just gonna go ahead and sketch this in, and it's not gonna look pretty. Yours will most likely look a million times better than mine. And if you really think yours is not good looking, then give it a little label with a radius of 4 so that I can see that you knew, but you just, you know, it didn't go well, okay? Because it sometimes doesn't go well for me. That's probably the best circle I will draw this whole entire summer. Okay, yeah, better than that one. I'm proud of this. Good thing it's on video. It's there forever. Something else I might do, or you know, when you're asked a question about circles, is they will give you a circle and ask you to write the formula, or the formula. So let's say that I gave you this guy. Let's go over 1, up 2. So we're going right there for our center, and we'll go there, there. Alrighty. Yeah, not as good as that guy. Okay, so there's my circle. So hopefully you're seeing that the radius that I'm giving you here is equal to 3. And you notice where your center is. So our center is the point we're going backwards 1, so -1 and up 2. So when we go to write the equation for, or the formula for our circle, we can say x minus h, so we're gonna go +1 squared, plus y minus 2 squared, and then we're not gonna put 3 here, we're gonna put 1. Okay, so we can write the equation of the circle, we can draw the circle, that's what we're looking for. Now, another circle that pops up and does become useful as you move into higher division math classes, so you will start to hear about this circle if you haven't already, is the unit circle. And the unit circle is like the basic building block or the base graph of the circle. And it looks like this: x squared plus y squared equals 1. So it's got the x squared and the y squared, the x squared and the y squared, but it doesn't have anything with it. And because there's nothing with it, that means that the center is 0. So the center to this guy is 0, 0, and the radius is 1. So this is just the little graph of a circle that's centered at the origin with radius 1. So there is your unit circle, sort of. Doesn't really look like a circle. Anyway, I try my best. All right, so the unit circle, so you're going to hear, probably not in Calc 1, but if you get into Calc 2 and Calc 3, all of a sudden the unit circle is gonna start to pop up. So you wanna be aware of what that one is. Now, the only crappy part about circles is that they don't always give it to you in this form. They give it to you in sort of a much uglier form. So let's go ahead and look at an example of that. And I'm going to erase kind of everything here so we have the whole board to work with. So this is what you get. 3x squared minus 6x plus 3y squared plus 4y minus 4 equals 0. Okay. And let's say that it said to graph this. Now in this format, graphing this would be a real royal pain in the ass. Okay, if you plug in like x equals 1, there's no way that you're going to figure out easily what y equals. It's just a mess, just a mess. So we got to do something with this. So when I look at this, I know that this is a circle because of two things. First is the x squared and the y squared. Okay, the fact that there's an x squared and a y squared. And the second thing, which is also important, is that the y squared has a plus on the front. Well, the x squared does too. They're both positive. Okay, so that plus and that being positive, and the x squared and the y squared. But none of the circles that I gave you here had a 3 on the front. So this is a mess because of the 3. So what we can do is we can divide, because it's equal to 0, it's set equal to 0, we can divide the whole entire thing by 3. Now it's going to help a little bit, but it's still going to be a little bit on the ugly side. So this is going to be x squared minus 2x plus y squared, and then here comes the ugly, plus 4/3 y minus 4/3 equals 0. Well, we got rid of the 3 in the front of the x squared and the y squared. That's good. We'll have to deal with the fractions later. Now, what I'm going to do from this point is I'm going to rearrange things. I'm going to take the x's and I'm going to clump them together. I'm going to take the y's, I'm going to clump them together, and the constant is going to the other side. So we're just going to rewrite again, and here we're going to have x squared minus 2x, and I'm going to leave a space, okay? And then I'm going to have plus y squared plus 4/3 y, and I'm going to leave another space. And then that guy is adding to the other side, so on the far side we'll have 4/3. Now, what we need to do is we need to get this into that x minus h squared format. So what we need to do is create a perfect square. And the way that we create a perfect square is by completing the square. So back in algebra, completing the square, maybe not your favorite thing, but here it comes. In order to complete the square, we're going to take our b term, we're going to divide it by 2, and we're going to square it. b divided by 2 and squared. So on this one, we're going to take -2 divided by 2 and square it. Now, -2 divided by 2 is just -1. And squaring that gives us a positive 1. So that positive 1 is going to go in this slot, plus 1. But I can't just add 1 to an equation just because I feel like it. If I add 1 to one side, I've got to add 1 to the other side. So we'll add 1 over here. Okay, now here's the ugly one. We're going to do the same thing, but our b in this case is 4/3. So we're going to take 4/3, we're going to divide it by 2, and we're going to square it. Now, another way to write that is 4/3 times 1/2 squared. And that's a little bit nicer, so we can cancel and cancel. So that's 2/3 squared, which is 4/9. Okay, so yes, it's a fraction, but at least it kind of simplified a little bit. So the number that we're putting here is plus 4/9. But again, if we put 4/9 here, we got to stick a 4/9 over here. Okay, now we did this because what we're making is perfect squares. And if you look at this, this guy factors as an x minus 1 and another x minus 1. So this guy is x minus 1 squared, which is exactly what we're looking for. Now, the y guy is going to factor just as nicely. It's just that normally when we see fractions, we kind of freak out and we go, oh crap, what's the factor going to be? Well, remember, we made this, we created it. So when we come over here and look at it, the guy right before you square it is your factor, plus 2/3, okay? So think about that. 2/3 plus 2/3 would give us 4/3. And 2/3 times 2/3 gives us 4/9. So that's our factor, we're good to go. All right, not so bad over there. Now on this side, everybody's gotta go to ninths, right? So multiply by 3, so that'll be 12/9 plus 9/9 plus 4/9. So altogether that is 25/9. Okay. And there we go. There is our circle, and it's equal to 25/9. So from here, I can ask for the center, and remember, we're gonna flip the signs. So the center on this one is 1, -2/3. And the radius here, we've got this 25/9, which we'll take the square root of, which will give us 5/3. So we had to use that completing the square to get where we wanted to go. And we did it once without fractions, but then we did it once with fractions, so that in case a fraction shows up, you can still do it. You can still do it, it's just a little bit uglier, but it wasn't horrible. Okay, and we're able to get the center and the radius. Alrighty, what do you think? Okay, so equations of circles, graphing circles, and then you're definitely gonna see it completing the square, so you might as well review this a little bit, okay? But that is it for circles. So 7.2 is done. We will come back and look at 7.3. All right, bye.